Hello and welcome everyone. In this video I want to talk about code structure in regard to timer callbacks in the context of JUCE based VST plugins. Just like in my last video, I will take my previous plugin releases as examples for how you can structure these kind of things, and then also show you my current template that I'm working on where I came up with a new strategy to deal with these kind of things. So here we have my plugin Manta, and if we look into the code of the button header, then we can see there is a structure called Blinky Boy which inherits from public timer and because of that implements the method TimerCallback. And there is also a button which inherits from timer and also implements TimerCallback. If we go into the CPP file, then we can see the Blinky Boy does something in the TimerCallback with an envelope value. It doesn't matter now too much what exactly it does. And the button just loops through a bunch of STD functions and calls them. That's something that I did a lot in this project and many other of my projects. I basically abstracted away the virtual function by just adding a vector of on-timer functions so that I can define what the timer should do from outside of the object of the button instead of having to define it inside of the button directly, in order to make it more flexible what the button should do or not do. But that also means that you have to have a lot of timer callbacks throughout your code. Like every other object has its own timer callback, and at some point you might just be wondering, wouldn't it be way less messy if there was just one timer callback and that one timer callback calls all of the other callbacks? And that's, for example, something that I tried to do when I rewrote the code in my plugin Nell recently. So here you can see my general component class that all of my components consist of. I have one of these in most of my projects, and this one does not inherit from timer, but it has a function called update timer, which is a virtual function, can be implemented, but you can also just keep it empty. And then, for example, here we are in the basic editor of Nell, and there I call update timer on all of the components that this editor holds. But you can already see that this is kind of messy. First of all, I'm repeating myself a lot and the code looks very boring, and it's like it doesn't really say anything, just, oh yeah, you keep on updating certain timers. And I can tell you just from when I rewrote this code that it was kinda error prone, because sometimes you forget to call certain components update timer function and then certain things are just not happening and you are just wondering why. I forgot the timer, and yeah, kinda messy. So now I came up with a new solution. So this new solution is based on something that I read. I think it was in the JUCE forum, or maybe it was in the audio programmer Discord, where it was suggested that one should wrap the public timer and its callback into its own little class in order to avoid having to inherit a lot of classes from timer. Tried this approach, but I took it a little bit further, as you will see. So callbacks is an array of vector of a callback, and a callback is an STD function. So this might look a little bit complicated now, but you gotta consider that I wanna support different frame rates. And I just decided that the base frame rate is 60. As you can see here, and all of the other frame rates are just, what's the name for that? Multiples, but like the opposite of multiples. Dividables, I don't know, but you know what I mean when you look at the numbers, right? So these get slower and slower. So you can add callbacks or remove callbacks. When you add them, you have to say at which FPS you add them with the help of this enum class. And then during the timer callback, I'm just looping through the different FPSs and get the callbacks out of it, and then use this calculation to find out at which FPS I should call the callbacks. The base idea is just that you call all of your callbacks that are in this two-dimensional array, and hopefully now you can see why it's a two-dimensional array, because the first dimension deals with a different FPS and the second dimension has to be a vector, because at initialization you don't know yet how many different callbacks you will actually add to this class. So this class basically manages all of the callbacks, so it has to sit in a place where there just needs to be one single instance of that and no copy ever of it throughout the whole project. So here we have my utils class, and the utils class sits in the audio editor and is also never copied anywhere, just references to the utils class are copied everywhere so that every component can work with the utils. So I decided that this would also be a great place for my TimerCallbacks object. So it lives here, and I gave my utils class some nice little functions for adding and removing callbacks as well, of course, to make it a little more straightforward. Now let me show you a little example of a callback that I added to my project already. You can see a background image here, and every time I resize the interface, it is being regenerated to fit the new size, not immediately, but at an FPS of 3 point something, to make it not too expensive on the CPU. You know, if you did this in 60 FPS, then some CPUs would be very unhappy about that. I think my computer would be fine, but I don't wanna offend a lot of other computers with this, especially when my images become more complex later. This is just a little test image. So this is using the callback system, and I will now show you what it looks like. So here we are in the background image component header. Here in the CPP file of the component, we can see the constructor in which I have this vector of callbacks on which I push back the callback that describes this functionality, which is if the image doesn't exist yet, return. If it does exist, get the width and the height of the component. And if the width and height did not change, then return. But if it changed, then update the background image and repaint component. And then you also have to call add callback on the utils with the given callback at the desired FPS. And that's basically it. At this point you have a callback, and you didn't have to let your background image inherit from TimerCallback, and also you don't have to let the background image hold its own object that has a TimerCallback. So it's like out of your mind, out of the way. And I realized this workflow in this way. Here we are in my component header, and you can see that the component header has a vector of callbacks. Here callbacks is defined differently than in the callbacks class. It is just a vector of callbacks, so not an array of vectors, but just the vector. Each component owns its callbacks, but the TimerCallbacks class only owns the pointers to those callbacks. And when the component is destroyed, it automatically removes the callbacks from the TimerCallback object, so that each object that inherits from component doesn't force the developer to manually delete these. As we all know, we don't like manual deletes, so this is how I make this automatic and smart. I really like the way I'm handling the TimerCallbacks now. I'm very happy with like the syntax that emerged from that and all that. So far at least. This project's not very big yet, so I can't really tell much about how it feels yet. I can just say my initial feeling is pretty good. One thing that I have to keep in mind though is that I'm not quite sure yet how safe it is. So far nothing ever crashed, but I'm constantly wondering if it could be possible in some circumstances that this loop is currently running and some callback is like being fetched from this array of callback pointers, while somewhere else a component is deleted and therefore its callbacks as well. I think it should not be possible because the entire GUI runs on the message thread, and the message thread likely isn't in this method and in some destructor at the same time, but I might be wrong, and you know, maybe at some point I will also get more into multi-threading, even though I'm not a big fan of that, and at that point I might have to put more attention to details like this. But for now I'm just really happy. Also tell me about your opinion about this callback system. How does your callback system work? What do you like about the ones that I showed you in this video, and what do you not like so much? I would really like to know more about the different perspectives that you can have on this topic.